So we are back with an example on sum and differences, but this time we're going to look at a tangent function. So far we did the sine function and the cosine function. Guys, now let us see how we can do the tangent function as well. First of all, if you look at the formula sheet, there's a separate formula for the sum of the tangent or the difference of the tangents. Guys, that's totally fine. If you want to use that formula for this one, that's fine, you can do that. But my suggestion would be not to use that formula, but rather to use the formula that tangent is nothing but simply the ratio of the sine over cosine. Okay, we already know that the tangent of an angle is the sine of an angle divided by the cosine of an angle, and that is what we are basically going to use here as well. That's going to make our life easier. Okay, but before we start doing it, we already know that if the angle is in the radians, first we want to convert that angle into degrees, and then we want to think about the sum or the difference based on the unit circle. Okay, so let's go ahead and convert this angle into the degrees. So I have 5 pi over 12. What am I going to multiply this to convert it into degrees? I think we should know that by now. We multiply by the ratio 180 over pi. So I multiply this by 180 over pi. Okay, what happens to the pi's? The pi's cross out. I have 5 times 180 over 12. You can use a calculator if you like. What I'm going to do is, I know 180 has to be divided by 12. 180 divided by 12 is 15, and 15 times 5 is 75. So it is equal to 75 degrees. So 5 pi over 12 radians is equivalent to 75 degrees. So that means we have to try to figure out what is the tangent of what? Tangent of 75. Okay, guys, it's easier to work with the angles in degrees rather than in radians. I mean, if you are good with using the angles or working with angles in radians, you can also use those, because on the unit circle we have both. We have the degree measure, we have the radian measure. Okay, but I like to use the degrees. It's easier to work with degrees. Now I have to think about like two angles, sum of two angles that add up to 75, or it could be the difference of two angles that add up to 75. It's up to you what you want to use. But both those angles should be on the unit circle, right? So 75 is something like, it's easy to figure out two angles that add up to 75. 45 and 30 both add up to 75, and they're both on the unit circle. So we can write this as tangent of 45 degrees plus 30 degrees. Okay. And now we have to, guys, keep in mind, we are not just trying to find the tangent of 75 using a calculator or using a unit circle. We want to use the sum and difference identities to do it. Again, you can use this just the direct tangent sum or tangent difference formula, which is on the formula sheet. I don't like to use that too often. I'm going to rather use the fact that the tangent of this is the ratio of sine over cosine, because we already know that tangent is the ratio of sine and cosine. So the first thing that I'm going to do here, I'm going to write this out as the sine of 45 plus 30. 45 plus 30 degrees, and then divided by the cosine, right? I just simply use the basic identity that the tangent is the ratio of sine over cosine. If it is theta, then it's theta here and theta here. If it is a plus b, then it's a plus b and a plus b. If it is 45 plus 30, then it's 45 plus 30 upstairs and downstairs. Okay, so it's 45 plus 30. Okay, so from here we have to use two formulas. We have to use the formula for the sine, and we also have to use the formula for the cosine, which is something that we have seen in my previous videos, and we should be able to do it using the sum identity. Well, for both we have to use the sum, but upstairs is sine, downstairs is cosine. So I'm just simply going to use it. So what do I have? I have sine of 45, then cosine of 30, right? Then plus cosine of 45, and then I have the sine of 30. I'm just simply using the sum upstairs, and then downstairs I have to use for the cosine. So I have cosine of 45, then I have cosine of 30. We have both cosines here, and then if we have a plus here, I have to use the minus, right? Minus, and then I have to use the sine 45 and sine 30 degrees. Guys, I simply use the formula that is already here, or which is going to be on your formula, on your the formula sheets. Okay, now we have to go back to the unit circle, and we have to substitute the values. Sine 45 is radical 2 over 2 times cosine 30 is radical 3 over 2, then plus cosine 45 is radical 2 over 2, and sine 30 is 1/2. And you divide this whole thing by the cosine 45, and so cosine 45 is what? Radical 2 over 2. Cosine 30 is still radical 3 over 2 minus what do I have? I have sine 45, which is radical 2 over 2 times sine 30. Sine 30 is 1 half. Okay. Use the unit circle. I remember these values, so I just put them down there. So guys, now simplify this. Let us not like get overwhelmed with this. We do one thing at a time. First we simplify the upstairs numerator and then denominator, and then see what we have to do from there. Radical 2 times radical 3 is radical 6 over 4. Then plus radical 2 over 4, right? And this whole thing has to be divided by, guys, this whole thing has to be divided by what? Let's see what the denominator simplifies to. Again, it is radical 6 over 4 minus radical 2 over 4. They're basically the same except for two different signs, okay? So there's a plus here, there's a minus here. We cannot cross anything out right away, but we can still simplify this expression, and we have to simplify. We cannot just leave it like this. Guys, if you're working on this problem on a test or a quiz, and if you leave it like this, you are not going to get full credit. You're probably going to get a partial credit for this. So we have to still simplify this. And since I'm out of space here, what I'm going to do is I'm going to make some space here, and then we're going to try to simplify this, okay? So let us get rid of this side here. And let us see how we can simplify this. Okay. So guys, since the denominators are the same, from here, I'm going to take it up right here. So can I simply do radical 6 plus radical 2 over 4 divided by, okay, I just combined the numerators, and you got to do the same thing for the denominator as well, because they still have the same denominators for the 4 and 4, okay? So you can combine radical 6 minus radical 2 over 4. Okay. So you have the ratio of two ratios. So when you have ratio of two ratios, what we try to do is we like to simplify this like this. We change this big division, right, into multiplication. And we know what happens. If I change that division, we transform that division into a multiplication, then this flips, right? The numerator becomes the denominator and the denominator becomes the numerator. So when we multiply, then this is going to be 4 over radical 6 minus radical 2, right? Guys, that is a simple mathematical operation that we should know, and we're supposed to know at this level. So 4's cross out, and what are we left with? We're left with radical 6 plus radical 2 divided by radical 6 minus radical 2, all right? And at this point, we might think that we are done. Yes, we are almost done, but keep in mind, we don't like to keep radicals in the denominator, okay? So since we still have a radical in the denominator, we actually have two terms with radicals in the denominator. So one has to still simplify a little bit. I know it's a lot of work, but guys, it is what it is. We got to simplify as much as we can, and we cannot have radicals in the denominator, so we got to still simplify. And you should know by now that to get rid of the radicals in the denominator, one of the methods is to actually multiply by the conjugate or rationalize the denominator. And how do we rationalize? It's not such a difficult process. So you take the quantity, right, radical 6 minus radical 2, and you multiply upstairs and downstairs. So I'm going to put that in the parentheses, and you multiply upstairs and downstairs by, I'm trying to make some room, and then you multiply upstairs by downstairs by the conjugate of the denominator. So conjugate means that this is going to be radical 6 plus radical 2, and you multiply by the same thing because you cannot change the ratio, so you got to multiply or divide by the same quantity. Now we try to simplify this. Simplifying this means you got to distribute, right? And all the radical 6 times radical 6, and I'm going to try to do it quickly, is simply 6. I mean, if you want to use a calculator for that, you can, but you can do it without a calculator as well. Then there's a plus, radical 6 times radical 2 is radical 12. Then I will have another radical 12. So I will have two radical 12s, which will add up to 2 radical 12. And then finally I have radical 2 times radical 2, which is going to be just simply 2. And then this whole thing has to be divided by, guys, here this is the difference of the squares. This is a minus b, this is a plus b. And we know that the difference of squares is what? Is the a square minus b square, right? That is equivalent to a minus b times a plus b. then that's what's happening here. So you've got to square the first term and the second term. But what is radical 6 squared? It's just simply 6 because the radical and the square crosses out. So downstairs I will only have 6 minus 2. Okay, so far so good. Let us simplify this further. So I have 6 plus 2, which is 8, and I have 8 plus 2 radical 12 divided by 4. Guys, look at this expression. It's almost simplified, but I think we can still do a better job than this. So what we can do here is there's an 8 here plus 2, and then radical 12. Guys, radical 12 can still be simplified. I mean, there could be times when you get something inside the radical that cannot be simplified. For example, radical 7, radical 5. So then you cannot do anything with that. You just leave them. But radical 12 can be simplified. And radical 12, I'm just trying to find any space that I have here. So radical 12, guys, you know how to simplify radicals. You try to break them down into product of 2 so that at least one of them is a perfect square. So for radical 12, you can do 4 times 3. And then radical 4 is 2, and radical 3 you cannot do anything, you just leave it like that. So radical 12 can be replaced by simply 2 times radical 3, right? 2 times radical 3. Don't forget this 2. This 2 is already outside the radical, so you just got to leave it like this. It is already in the simplified form. And this whole thing is divided by 4. Okay, now guys, 2 times 2. 2 times 2 is going to be 4. So it is 8 plus 4 radical 3 over 4. Please look at that step carefully. From here, combining like terms, then plus 2 radical 12, downstairs 6 minus 2 is 4. We got up to there. Then we look at this radical 12, then, I mean, one may think that we are done, but then we look at the radical 12 and we see like, hey, radical 12 can still be simplified. We take it up on the side and we see that radical 12 can be broken down as radical of 4 times 3. Radical 4 is 2, radical 3, just leave it like that. And then we bring it back here. So radical 12 is replaced by 2 radical 3. And we leave that 2 outside. Then 2 times 2 is 4. 8 plus 4 radical 3. Guys, we're still almost done, but there's one more thing we can do. So let me see if I can simplify this as well. So I'm going to take this up. We can make a little more room here. I'm trying to use the board to its maximum capacity. So guys, 8 plus 4 radical 3 over 4. Guys, I'm really sorry that I have this all over the place, but I'm sure you will be able to follow. We got to here, then there's the arrow here which takes us all the way down here, and now finally we are doing our last piece. Okay, from here guys, you can clearly see that this 8 and 4 has a common factor, the greatest common factor 4, so you can take it outside, and whenever we have a greatest common factor and when we are simplifying things, we have to write the factors. We have to go all the way to the end to simplify. So take out the 4, what is left inside? 4 times what gives me 8? 4 times 2 gives me 8, and 4 times what gives me this? I just simply have radical 3, and then there's a divided by 4. Okay, we just took out the greatest common factor because we can take out, there is a greatest common factor. If I didn't have a greatest common factor, then I just leave it like that. Then I cannot simplify any further. But here I have a greatest common factor, so I took it outside, and what is left inside is 2 plus radical 3. Guys, the last step, finally the last step is like this 4 and this 4 crosses out. And finally, my final answer to tangent of 75 after all this work is 2 plus radical 3. Okay, guys, this is a lot of work. I know this is a lot of work, but to make sure that it looks radical 3, this is the final answer for tangent of 75. Guys, this is a lot of work, but I mean, here I don't have too much space to do all of this. I'm sure when you will be doing it on your notebooks, you will have enough space to write all the steps and go back and check your work. So do the steps carefully, write all the steps carefully, look at the unit circle, use the values, then simplify. And one has to simplify as much as one can, and we cannot stop here, we cannot stop here. We think we would stop, but then we know that we cannot have radicals in the denominator. So in order to get rid of the radicals, we got to rationalize, multiply by the conjugates. Then when we do it, then we got something like a radical 12. So we got to simplify radical 12, bring it all together, then take the greatest common factor, and finally find the final value. So I mean, I decided to do this example because this example requires a lot of math concepts. So I wanted to share those concepts with you, and there is going to be examples where you are going to be needed to use more than 1, 2, or 3 math concepts, and one has to like prepare themselves for these types of problems as well. Okay, so guys, we did sum of the sine, cosine, tangent, and we'll still continue the sum and the difference identities, but we'll do some different types. Okay, till then, take care and keep practicing, guys. If you again need any help, any hints, please reach out to me through my comments, through my YouTube channel, through the comments, and I'll be happy to like assist you or help you in any way I can. Okay, thank you.